Hello students, welcome to class. How are you doing today? I hope you've been doing very well. This is Miss Adana, and in this class we'll be looking at a topic in chemistry for SS1. So far so good. We've treated topic for week 1 to week 6. So in this particular class, we're looking at week 7's topic. So let's look at that. The topic for this week is carbon and its compounds. So we're looking at carbon and its compounds. Our learning objectives are: 1, describe the unique characteristics of carbon as an element, define the term allotropy and state the allotropic form of carbon, describe the structure, property and uses of diamond and graphite, distinguish between diamond and graphite, describe the amorphous form of carbon and their uses, and then should be able to describe the destructive distillation of coal, the products of destructive distillation of coal, and their uses. These are the things we hope to achieve at the end of this class. So, moving on, carbon. Now, carbon is an element which is a non-metal. Carbon is a non-metal and it has atomic number 6. So its electronic configuration is 1s2, 2s2, 2p6, or 2,4 using the shell configuration. So from this electronic configuration, it shows that carbon has valency of 4. So it uses those electrons in its outermost shell to form bonds with itself and then with other elements. So because of this valency, it has the ability to form stable bonds with itself and other elements. So another unique property of carbon is its ability to catenate. Now, when we say catenate, catenation means the ability of an element to form a framework of itself. So a continuous framework of itself. For example, if you look at these images, you see carbon, there is linear chain. That is straight chain of carbon, branch chains, then you have cyclic ring or ring form of carbon. So it's among all the other elements that exist in the periodic table, only carbon actually has this ability. The only element that comes close is silicon. But the one of silicon are very unstable and can hardly go beyond 10. But for carbon, carbon can form framework of itself up to 1,000 and even above. So because of that, you have vast number of carbon compounds. And carbon is very essential, is a very essential component of all living matter. Now, carbohydrates, proteins, fats, and oils, these are living matter and they are majorly composed of carbon compounds. Then in fuels, you have petrol, woods, cooking gas, they are made up of carbon compounds. So carbon is a very, very important element that constitutes majority of the things we use at home. Even, for example, plastics, shoe polish and stuff like that, they are made up of their major component is carbon in form of compounds attached where other elements attach themselves. So carbon is a very important element in the periodic table. Now, next one we are looking at is allotropy. Allotropy is a term used to describe the existence of an element in 2 or more different forms in the same physical state. What this means is that carbon as an element can exist in different forms in the physical state. Now, there are 2 major forms in which the carbon can be classified based on its allotropy. We have the crystalline carbon and the amorphous carbon. The crystalline are diamond and graphite. Then the amorphous form are charcoal, soot, and coke. Now, let's look at the crystalline form. You see, these are crystalline form. The one on the left is diamond, while the one on the right is graphite. Another look, diamonds, graphite, they are the crystalline. But look at this. This is the amorphous form of carbon. You see, the form is different. The same element existing as this amorphous form and existing as this crystalline form. So this property is known as allotropy, existence of an element in different form in the physical state. So next, let's look at each of them one by one. Diamond. Now, diamond is the purest form of naturally occurring carbon and is the hardest substance known. Now, diamond is octahedral in shape, and the carbon atom. Now, if you look at this image, you see each of these represents carbon. They are held by covalent bonds, strong covalent bonds, and they are closely packed together. So because of that, carbon, the carbon structure is very stable and very pure. So because of this property also, carbon has diamond has high melting and boiling points. So it has very high melting and boiling point, and so it cannot conduct electricity because the carbon atoms, all the carbon electrons in diamond have been used up. So there is no free electron that when electricity is applied can conduct electricity. So that's why carbon cannot conduct electricity, or is a non-conductor of heat and electricity. So another property of carbon, like we said, is the hardest known substance. The diamond is the hardest known substance. That's another property of diamond. Then we said it's octahedral in shape, is a non-conductor of heat and electricity. Then chemically, diamond is very unreactive, but it will react with oxygen in air at very high temperature to form carbon 4 oxide. Now, all these are in your note, so please go to your note and you see them there. So at very high temperature, it will react with oxygen in air to form carbon 4 oxide. So these are the properties of diamond. Now let's look at the uses of diamond. Now, because of the hardness of diamond, like we said, the hardest known substance, it is used for making cutting tools because it's very strong. So tools that can be used to cut very hard substances. Diamond are used for them. They are used for drilling, in mines, and they are used for abrasive. That is abrasive in sharpening very hard surfaces. Then, because of its refractive index, it has very high refractive index. That's the common thing we know diamond to be used for. Is used for jewelries, making jewelries, and you all know that that's quite expensive. But majorly, diamond is used industrially to make all those things that I mentioned before. So now the next thing we are looking at is a graphite. Now, graphite is black and slippery to touch. It's a black solid. Now, compared to diamond, diamond is transparent and very hard. In fact, the only substance that can break diamond is diamond itself. So diamond is only used to cut diamond. Other things will be broken by diamond. So diamond, which is the first form of the crystalline form. Then looking at graphite, now graphite is black and slippery. So a little application of force on it, we break it apart. So it's slippery to touch. Now, in terms of structure, graphite is hexagonal in shape. Now, it consists of flat layers of carbon atoms joined together by covalent bonds, and then these flat layers are now held by van der Waals forces. Now, if you look at the image, you see the straight lines are carbon to carbon covalent bond. Each of these represents a carbon atom. So you see carbon to carbon covalent bond. Then you see dotted lines which show van der Waals forces holding the layers together. Now, these layers are in parallel and they are held by van der Waals forces. So because of this property of graphite, it is slippery. So it is used as a lubricant, especially in in machines where high temperature is always used. So when those in such machines that can quickly melt ordinary lubricants, graphite is used. So graphite also have high boiling point, but its boiling point is relatively lesser than that of a diamond. Then another property of graphite is that it is a very good conductor of heat and electricity. Now, it can conduct electricity because there are free valence electrons in graphite structure that can easily move when electricity is applied to it. So when electricity is applied to a graphite molecule, those free electrons can now move, and so they conduct heat and electricity. Then, like diamond, it's also very unreactive, but it also reacts at high temperature with oxygen in air to form carbon 4 oxide. So these are the properties of graphite. Now, uses of graphite. Graphite is used in combination with clay to make pencils. That lead pencil, the lead in pencils are made from graphite in combination with clay. So because of that slippery nature of graphite, when you are writing on paper, it can slide off and mark the paper. So that's one uses of graphite. Then it's also, I mentioned just a while ago that diamond is used for making lubricant, especially for machines with high temperature. So those are the uses of graphite. Now, differences between diamond and graphite. I said it occurs naturally in free state. That's one difference. And for graphite, it occurs naturally and is manufactured artificially. Diamond is the hardest known substance, while graphite is soft and grisly to touch. Then it has diamond has high relative density, about 3.5, while graphite has relative density of 2.3. Diamond is transparent and has high refractive index, but graphite is black in color and opaque. Now, diamond is a non-conductor of heat and electricity, but graphite is a good conductor. It burns at 900 degrees centigrade to give CO2, that's carbon 4 oxide, while graphite burns at 700 to 800 to give carbon 4 oxide. Then their shape, in terms of shape, diamond is octahedral, while graphite is hexagonal. Now, the next one we are looking at is the amorphous form of carbon. Now, the first form of amorphous form is charcoal. Now, I'm sure you know what charcoal is, but there are different forms of charcoal. You have wood charcoal, animal charcoal, and sugar charcoal. Now, each of these are made by burning these substances in limited supply of oxygen. For example, wood charcoal is made from burning wood in limited supply of oxygen. Animal charcoal is made from burning bones or even blood in limited supply of oxygen, while sugar charcoal is made by dehydrating sugar. Now, dehydration means removal of water from a substance. So, water is removed from sugar and it forms something like this. So you see the difference from, you have wood, animal charcoal, and sugar charcoal. Now, wood charcoal is majorly used locally in Nigeria as fuel, cooking. Now, when you see around, you see these people that roast corn and all that, they use this wood charcoal. Then another use of wood charcoal is it's used to absorb poisonous gases from the air. So it is a good absorbance. Usually charcoals are good absorbers, so it's used to absorb poisonous substances from the air. Then animal charcoal is used as a decolorizing material. That is used to remove color from substances. For example, animal charcoal is used to decolorize brown sugar. So in industrial processes, animal charcoal is used in brown sugar to remove that brown color, which the sugar we have at home is now colorless in nature. But actually, the brown color was removed by animal charcoal. Then sugar charcoal is also a good substance that is used for absorbing color in substances. Now, the next amorphous form of carbon is soot. Now, soot is obtained by burning oils. Now, liquid fuels, for example, kerosene. When you burn kerosene, you notice that at over time you see collection of black substances in that very burner, or maybe in your fuel or generator. You see, after a process of time, you see collection of black substances. That substance is known as soot. So it's obtained by burning liquid fuels or oils in limited supply of air. Now, the uses of soot is that soot is used in making painter's ink, used in making painter's ink, shoe polish. Now, soot can also be known as lamp black. So it's used for making printer's ink, also used for making shoe polishes and cardboard paper. Those are the uses of soot. Next one is coke. Now, coke is one of the products of the destructive distillation of coal. Now, let's quickly look at coal, then we'll come back to talk about coke. Now, coal itself is a mixture of organic and inorganic compounds, which is made up of carbon compounds combined with hydrogen and oxygen, and then you have little impurities of nitrogen, sulfur, and phosphorus in the carbon. Now, if you look at this structure, this is the way coal looks like. And in Nigeria, coal is found in large quantities in Enugu State. So now, coal can be converted to other products through what is known as destructive distillation. That means heating coal to a very high temperature in the absence of air. Now, look at this, is usually the setup. So you have coal being burnt in the boiling tube. Then you see the products are coal gas, you have coal tar, and then you have ammoniacal liquor, and then you have coke. These are the four major products gotten for coke from the destructive distillation of coke. Let's look at them one by one. Coal tar. Now, coal tar is one of the liquid fraction of or one of the liquid products of destructive distillation of coal. Now, this coal tar can be fractionally distillated. That means it will be put under fractional distillation, and you obtain products such as benzene, toluene, phenol, naphthalene, and pitch. Now, each of these fractions of coal tar have their uses. For example, benzene is a solvent used in the manufacture of plastics, dyes, and is also added to motor spirits. In motor spirits. So benzene, these are the uses of benzene. Then toluene is used as explosive, in making explosive. Then phenol is used as disinfectant and in making drugs like aspirin. Then pitch is used in road surfacing, like you call that coal tar, but coal tar itself is fractionally distillated to get this other product. But when the byproduct of fractional distillation is peat, which is used to do road surfaces during road construction, then you have naphthalene. Naphthalene is used in making mud boards, for example, what we call camphor. So we use naphthalene is used for making that, and then it's also used for making dyes. Then the next one is ammoniacal liquor. Now, ammoniacal liquor is a mixture of water and ammonia. During the destructive distillation of coal, ammonia mixes with water to give us ammoniacal liquor. Now, the uses of ammoniacal liquor is that it can be used to make substances like fertilizer, most especially. So it's used to make such substances. Then next one is coal tar. Coal gas. Coal gas is the gaseous form from the destructive distillation coal, and it's a mixture of gases. So there are different gases, most especially you have methane, hydrogen sulfide, and other gases mixed together in that gas. So usually this coal gas is used as fuel, maybe in cooking, both industrially and domestically. You can use coal tar. Then the last one is coke, which is an amorphous form of carbon. That means coal itself is a carbon compound that is joined together, but coke is actually about 98% carbon alone. So now coke is used majorly as fuel. It is used as fuel also. Then it is used to produce water gas and producer gas. So producer gas are like I said, coke is a non-volatile residue. That is like the solid form from the destructive distillation of coal. Now, water gas, when coal is burnt, when coke itself is burned in a stream of water, that is steam, gaseous water. When steam reacts with carbon, it will give you hydrogen gas and carbon 2 oxide. Now, water gas is a approximately equal volume of hydrogen and carbon 2 oxide. These gases mix together. Now, if you see these two red, this two mixture is known as water gas, and they are majorly used as fuel. Then producer gas, and also it can also be used to make produce hydrogen in the industry. The producer gas is a mixture of nitrogen and carbon 2 oxide. How is this producer gas made? Now, coke is passed through a stream of air. Now, you know that the major component of air is nitrogen and oxygen. So that coke reacts with nitrogen and oxygen in the air to give you nitrogen and carbon 4 oxide. That's the first product, the intermediate product. So by the time you apply more coke to the product to that intermediate product, you now have nitrogen and carbon 2 oxide. This is known as producer gas. So water gas is a mixture of hydrogen and carbon 2 oxide, while producer gas is a mixture of nitrogen and carbon 2 oxide. And I said producer gas is formed by passing a stream of air through coke. So it will produce nitrogen and carbon 2 oxide. Now, you need to note here that nitrogen as an element is unreactive. So that's why in producer gas, it does not actually react, but the oxygen in air will react with coke to give us carbon 4 oxide as the intermediate product before, when you add more coke, to now give you the producer gas itself. So I hope you understand this. So this is where we are going to end the class for today. Please try as much as possible to play the video 2 or 3 times so that you can get a better understanding of what I've just said. So, but in case of any question, please try as much as possible to contact me and I will answer your question. And then make sure you copy your notes, and there are assignments that is already on the school website that you need to look at and practice them. They will actually help you to understand better what I've said so far. So your references is your uploaded note for week 7 on the school website. They have New School Chemistry by Ababio, and then you have exam focused chemistry by Ohia. So please try as much as possible to keep studying your book and doing the right thing. Thank you very much. Keep staying safe until I come your way next time. I am your teacher, Miss Adana. God bless you.